Hi friends, welcome back. Today we are going to discuss one very important Java collections framework class TreeSet and two of its very important methods floor and ceiling and how they work with some examples. Before we start looking into the details of this problem, I would like to quickly mention that this channel is to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, Java programming and coding. So please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. So this is a TreeSet class that we are going to discuss today. This is another very important Java collections framework class. It is in a java.util package, right? So this is a TreeSet which is a implementation of a set interface. So it is just like a similar to hash set, but the difference between hash set and tree set is that in tree set the objects are uh, ordered basically in a sorted order, right? So here it will keep sorted order. So as you can see, a navigable set implementation based on a tree map, the elements are ordered using their natural ordering or by a comparator provided at set creation time. So I'm going to show you how we can implement comparators and sort the elements in the tree set, right? So I created an example for you here. So we'll go through that example and we are also going to see two of its very important methods. Before that, let's take a quick look at these important methods here. The time complexity. So login is the time complexity for the basic operations add, remove and contains, right? And these are the overloaded constructors of TreeSet class. The important method here are add, ceiling, floor, contains, first, right? These are important methods. Higher, lower, poll first, poll last. So these are some important methods. So we are going to go mainly today in the floor and ceiling method, right? So I'll explain you what that floor method does and ceiling method does with some examples, right? So let's say you have created some employee objects. Let's say you have 6 employee objects and you put these employee objects into a set, right? So you put these employee objects into a set and currently the employee objects right now is sorted based on the age, right? So as you can see here, this is sorted based on the age in an increasing order, right? So age is 24, 28, 32, 36, 50 and 60. So they are sorted based on the age right now, right? So if I do a floor, let's say if I do a floor method, right? Floor method, right? So let's say I have a floor method and if I pass here the integer 40, right? 40. So I want to find out employee which is less than or equal to 40 age but greatest value, right? Less than or equal to 40 but greatest value, right? So here which are those objects which are less than or equal to 40 age? So this 24 is less than equal to 40, 28 less than equal to 40, 32, 36, right? 50 and 60 is not less than equal to 40. So this 24, 28, 32, 36. So I want to find out the value which is less than or equal to 40 but the maximum, right? Less than or equal to 40 but the maximum. So this is the value, right? 36. So as you can see, this is how the result will look like. So this is the ID4, right? Its age is 36, correct? Age is 36. So this is how the floor method works, right? So it will help us identifying an employee with age less than equal to 40 but maximum, right? So this is what that floor method does, correct? So if you look into the documentation of this floor, right, return the greatest element in this set less than or equal to the given element or null if there is no such element, right? So this is how the floor method will work, correct? So we'll demo this with examples. So the same example we can demo. Now if I want to use another method is also there. If I want to find out a value again which is greater than or equal to 40 but smallest value, right? Greater than or equal to 40, which are values here which is greater than equal to 40, 50 and 60. These are the ages which are greater than or equal to 40, but I want to find the smallest in them, correct? The smallest is 50. So this is what the ceiling method will give me, right? So this is what the ceiling method will give me. So I'll show you the ceiling method now. Ceiling method, right? So let's go back, and here it's the ceiling method, right? So returns the least element in the set which is greater than or equal to the given element, right? Least element which is greater than or equal to given element, or null if there is no such element. So this is the method we will demo. These are two very important methods of TreeSet class, and very useful method to solve many programming interview problems as well. That's why I'm demonstrating these two methods, right? So you understood what this ceiling and floor method does, right? So right now the example we have seen here is using a comparator which is based on the age in ascending order, right? Age is in ascending order. I'll show you another comparator where we will use salary in ascending order, right? As you can see, there is another column here, salary, right? Salary. So salary, we will write another comparator, and I'll also demo you another example where we will use a different comparator where we'll create a salary with ascending order, right? So I hope you understood this concept of floor and ceiling, correct? So before we do that, um, before we go to the Java code, I'll just one more time explain you. So let's say you have an employee object. So you must have already got it clearly, but I just wanted to show you one more time. So let's say these are your employee objects, let's say, and these are their ages, right? 40, 50, like this, correct? So these are the objects basically, right? With age 10, 20, 30, 40, 50, and you put these objects into a set, into a tree set basically, right? Tree set will keep them in sorted order. Now the first method we will demo is um, floor, right? Floor. So let's say I'm calling a floor method and I want to find out employee which is less than or equal to 25, correct? So in that case I will get 20 as my answer, right? Because there are two employees which are less than or equal to 25, 10 and 20, so it will give me the maximum, so it will give me 20 for floor, correct? If I again call the same method which is ceiling method, not same method, with same argument is same, 25, so it should give me the employee which has a age greater than or equal to 25 but smallest. So this one is my answer. So I'll get this employee 30 using ceiling method, right? Because there are three values which are greater than or equal to 25 here, but it will give me the smallest one in them, correct? So this is what that floor and ceiling method does. Okay, so now we'll go to the Java class, but before that I'll show you a employee bin that we are going to use, right? So this is a plain old Java bin, right? It has couple of fields. So ID, first name, last name, salary, age, department designation, address on address to city, state, zip, country, right? So these are couple of fields of employee class. So we'll create 6 employee objects with ID starting from 1 to 6, right? So first we are going to create these 6 employee objects that I discussed, right? So employee 1, then employee 2, employee 3, employee 4, employee 5, employee 6, right? And then we will create a test employee so that we can test our ceiling and floor method, right? So this test employee ID is 20, right? So its ID is 20 and it has a name, right? As you can see, name, last name, salary is there. So the age of this employee is 44. The age of this employee is 44. So as you can see, if I'm calling a method 44, let's say these are my tree set employees, right? So as you can see, right, so I'm calling it 44, the floor method. So 44 floor method will give me the 36 as the answer, correct? Because 36 is less than or equal to 44 and largest value, right? If I use floor method. If I use ceiling method on 44, it will give me 50, correct? 50. Okay, so this is what first we are demonstrating. So now I will create a tree set which will hold employee objects, and we are going to pass a comparator here, so that the tree set will know how to sort the employee objects and keep those objects inside the tree set. So we are going to use employee comparator, and we are going to add these 6 objects into that tree set, right? So this is one important thing. Now how employee comparator works. So now here this comparator is based on the ages and it is in ascending order. So employee comparator is a static class that is implementing comparator interface for employee. So we have to implement compare method on two employees O1 and O2, and we are going to use the age field for comparison here, right? So O1 dot O2, if it is same age, you will return 0. Otherwise you will return O1 is greater than O2 age, then you will return 1, otherwise -1. So essentially we are sorting the employees based on the ascending order of age, right? So if age compare is not 0, we'll use age comparison. Otherwise, if both are same ages, we will use ID for comparison, right, in ascending order. So this is our employee comparator, which is essentially using age comparison, right? So this is what we are going to use here when we are declaring a tree set, right? We are defining a tree set here. So tree set, in the constructor we have to tell the tree set what kind of how to compare the objects basically. So we are passing the instance of the employee comparator, correct? Here, after we add all these 6 objects into the tree set, we are going to print those objects so that I can show you the current order in that tree set, how the objects are um, arranged in the tree set, right? That's why we are actually using iterator on the tree set. We are getting the employee objects in the tree set and displaying the employee object here, right? So this part is clear, right? So this is how the employee objects will be displayed actually, correct? Like this. So ages are in ascending order: 24, 28, 32, 36, then 50 and 60. So age is in ascending order because we use that comparator there, right? That's why. Now after this one, we are now going to test our two methods, right? First is the floor method on the eTest employee, the test employee that we created. We are going to test our floor method on this. So as you can see, the age is 44 here. So if we are using 44 and we are actually calling floor 44, we should get 36 employee here, right? 36. So let's test this out first. So I'm going to show you how the code works so far, so you will understand this. So first, here until this point we have printed the employees in the tree set. As you can see, they are printed based on the age ascending order. So 24, 28, 32, 36, 50 and 60. So this age is ascending order, right? Okay. Now we are, after that we are calling the floor method on the eTest object, right? So this is our eTest object. You can see the eTest object is this one. Its age is 44. So 44, so you will get this employee, right? Because this is less than or equal to 44 and maximum value here for age, this one, correct? So this is what you are getting here, and we are printing our result here, correct? 36. If I use ceiling, then I should get 50 for 44, correct? So let's try that now. So now instead of floor, now we are going to use a ceiling method, correct? So we'll use ceiling method. So this is our ceiling method on the same eTest employee, right? So we'll again run this. As you can see, now we are getting a ID 5 employee when we are doing ceiling method on eTest employees, which has a 44 age. So it is giving us the value which is greater than equal to 44 and smallest value. So 50 is the one, right? So you are going to get 50 here, right? So this is how the floor and ceiling method works, right? So this is clear to you now. Okay, so now I am going to show you another so this is similar example, but we will be using another comparator here, right? Another comparator. So we'll be using a salary comparator when we add the employees, correct? So we will just comment out this part because we will use our own other code now, right? So other part will be staying same. The only change will happen is how we are creating our tree set, right? How we are creating our tree set, right? Okay, so let's first, same thing, we'll test two methods, right? First is the floor and other is the ceiling. Now here I'll show you the comparator, right? So this was our first, this is our comparator now that we'll be using, which uses salary for comparison, right? So employee salary comparator, it is implementing again a comparator interface on employee. So we have to implement compare method with on two employees, right? O1 and O2. If both the employees have same salary, then we'll return 0. Otherwise, we will compare the salary based on its ascending order, right? So O1 dot salary greater than O2 salary dot salary, you will return 1, otherwise -1. So if you can use salary comparison, if they are different salaries, you will use that. Otherwise, you will just use the ID comparison in ascending order, right? So this is our salary comparator we are going to use now on our another tree set, right? So we just created this another tree set. We'll call it as a tree set 2, set 2, right? Here it is using employee salary comparator. Again, we will have the same 6 employees we are adding into this tree set, printing those 6 employees, and after that we are calling a floor method on our test employee. And test employee has what salary? It has 90,000 is the salary of test employee. This is our test employee. His salary is 90,000, correct? So let's run this code now. So first thing, we will take a look at this part. Okay, so these are the 6 employees. As you can see, they are arranged based on the salary in ascending order: 20,000, 24,000, 40,000, 80,000, 148,000 and 180,000, right? So they are in ascending order of salary, right? Now your test employee has a 90,000 salary. So when you call a floor method, it will give you the employee less than or equal to 90,000 but maximum value. So this is the employee which is less than equal to 90,000 but maximum value is this one, right? ID 1 Amit Patil, salary is 80,000. So we are getting correct answer, as you can see here, right? Okay, so this is a floor method. Now we will check ceiling method. So we'll comment this part and we will now check ceiling method, right? So ceiling method should give you this employee now, right, on 90,000, because it's the next greater than equal to 90,000 and smallest value 148,000, right? ID is 5, name is Sunil, right? So let's execute this. So as you can see, we are getting a correct answer here. ID is 5, name is Sunil, and its salary is 148,000, right? So this is how the floor and ceiling method works. So I hope you clearly understood both these very important methods here that we wanted to see today, right? So if you want to also see, there is a first and last method also. So I'll quickly show you those two methods also here. So the first method, right? First method will give you the first employee in this set, correct? So the first employee will be ID 3. So let's take a look. So you are getting ID 3 employee, which is the first employee in this set, correct? And the last employee you should get 6. So there is a last method also that you can use here, right? Last method. So last method should give you the last employee, right? So last employee is ID 6. So you are getting correct answer here, ID 6, right? So these are other two methods also which are important one. First and last will give you the first and last employee in the tree set, right? So this is what we wanted to see today, how these important methods work, floor and ceiling, and we also saw first and last method, right? So this is a important class which is a tree set class. This is another very important Java collections framework class, implementation of a set interface. The difference is between hash set and tree set is that tree set keeps the objects in sorted order, correct? So make sure you go through this documentation, read this documentation, understand these important methods. Also take a look at how these methods work internally, right, with some examples. There are other methods also you should practice, like for poll first, poll last, right? You can try that on your own. These are also simple methods. Contains method is also a simple method that you can try, right? So I'm going to add this Java solution code that we have learned today in my GitHub repository, so that you can check it out and play with the code. Uh, if you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. In the GitHub repository, you will find lots of other important Java solutions available there that are important from interview perspective. So do check out those codes and practice those codes as well. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview preparation process. It is called as Lead Code and Lint Code Solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them thoroughly. If you go through those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of problem solving. So do check out the solved coding problems. The name of the playlist is Lead Code and Lint Code Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems for your interview preparation, we have created 3 other playlists to help you there. The names of those playlists are Code Forces, Code Chef, AdCoder. Go to the playlist of this channel, you will find all those important playlists available there along with other important playlists. So do check out the other problems in the playlist. There are lots of interesting and important problems which come with Java solution code as well. If you like this today's solution and this today's video, how we have demonstrated the floor, ceiling, first, last method of an important TreeSet class, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. So do subscribe to this channel, share this video with your friends and colleagues so they will also watch and learn from these videos. Click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others learn how to solve different problems and implement their solutions in Java. On this channel you will find lots of solved coding problems which are very important varieties, including graphs, matrices, binary search trees, binary trees, breadth first search, depth first search, Cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are also lots of important data structure questions available for you here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All of them are important problems. Make sure you go through them, understand them very well. If you are a fresher, junior level developer planning to take Java interviews, there are lots of Java related videos we have created to help you here. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables, they will ask you to write SQL queries, where you may have to use different database concepts like inner join, outer join, aggregate operations, group by and having clauses, different where clause conditions, ranking functions, windowing functions. Everything is demoed and explained in those videos with database tables, examples and SQL queries for your easier and clear understanding. There are videos that discusses Unix questions as well here. For example, Unix commands, Unix utilities, shell scripting questions. So do search for those videos, take a look at those videos. Those are also recently asked questions to the freshers. If you like the videos on this channel, if they are helping your learning process, you are learning more techniques along with problem solving, Java programming and coding, then please do leave your messages, your feedback, your comments below these videos. Your messages, your feedback, your comments are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos. So do leave your messages, tell us how the videos are useful and helpful for you. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then mention those topics as well in the comments section below these videos so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning purpose and process going on continuously. And thanks for watching these videos.